reagents. Let's first start with a sample problem. How many grams of sodium chloride could you produce if you started 3 grams of chlorine gas? So we want to know how many grams of sodium chloride would be produced from 6.33 grams of chlorine gas. This is a typical stoichiometry problem. We need to go from 6.33 grams of chlorine to moles of chlorine, and we'll do that with the molar mass of chlorine gas, which is 70.90 grams. Then we need to go from moles of chlorine to moles of sodium chloride, and we know from the balanced reaction that 1 mole of chlorine gas makes 2 moles of sodium chloride. And once we get to 2 moles of sodium chloride, we need to figure out how many grams that is. So we need to convert moles of sodium chloride to grams of sodium chloride using the molar mass. Setting up our problem, question mark grams of sodium chloride is equal to 6.33 grams of chlorine, dot line. We want to cancel out grams of chlorine, so we're going to put the molar mass of chlorine, in the denominator, which is equal to 1 mole of chlorine in the numerator, and the grams of chlorine cancel out. Then we need to convert moles of chlorine to moles of sodium chloride. So 1 mole of chlorine is equal to 2 moles of sodium chloride, and the moles of chlorine gas cancel out. And then finally, we need to convert moles of sodium chloride to grams of sodium chloride using the molar mass of sodium chloride. We know that 1 mole of sodium chloride is equal to 58.5 grams of sodium chloride. So moles of sodium chloride cancel out. We multiply all the numerators together and divide by the denominators, and we get 10.4 grams of sodium chloride. Let's look at a similar problem. How many grams of sodium metal would you need to react with the 6.33 grams of chlorine gas in order to make 10.4 grams of sodium chloride? So now we want the number of grams of sodium metal we need to react with the 6.33 grams of chlorine gas. So we need to go from grams of chlorine gas to grams of sodium. To go from grams of chlorine gas, we need the molar mass of chlorine gas, which is 70.90 grams. That will convert it to moles of chlorine gas. From the balanced reaction, we know for every mole of chlorine gas, we're going to need 2 moles of sodium. And then to figure out the grams of sodium, we're going to need the molar mass of sodium, which is 23.0 grams. Then we set up our problem. Question mark grams of sodium is equal to 6.33 grams of chlorine gas, dot line. We want to cancel out grams of chlorine gas. So we're going to put its molar mass in the denominator. 70.90 grams of chlorine gas is equal to 1 mole of chlorine gas. And the grams of chlorine gas cancel out. Then we need to convert moles of chlorine gas to moles of sodium. And we know for every 1 mole of chlorine gas, we're going to need 2 moles of sodium. So the moles of chlorine gas cancel out. And once we've converted to moles of sodium, we can convert to grams of sodium by multiplying by the molar mass of sodium, which is 23.0 grams per mole. Notice that the moles of sodium cancel out. We multiply the numerators together and divide by the denominators, and we get 4.10 grams of sodium is needed to react with the 6.33 grams of chlorine gas in order to make 10.4 grams of sodium chloride. Now, what if you only had 3 grams of sodium metal? So instead of the 4.10 grams you would need, you only have 3 grams of sodium metal. Would you still be able to produce 10.4 grams of sodium chloride? No, you wouldn't, because you don't have enough sodium metal. Sodium metal in this case is referred to as the limiting reagent. The limiting reagent is a substance that is totally consumed in a chemical reaction. It's a stuff that you don't have enough of. So once you're finished with that reagent, once you've used it all up, your reaction is finished. So let's look at this. When 6.33 grams of chlorine gas and 3 grams of sodium react together, how much sodium chloride is produced? We already know we're not going to get 10.4 grams. We want to know the grams of sodium chloride are given. We're given actually 2 amounts, 6.33 grams of chlorine gas and 3 grams of sodium. If we calculate 6.33 grams of chlorine gas, we'd end up again with our usual answer, but we know we don't have enough sodium. So we have to calculate this answer from our limiting reagent, because once we use up all our sodium, That's as much product as we're going to produce. So our limiting reagent is 3.00 grams of sodium. So to go sodium, we're going to need the molar mass of sodium, which is 23.0 grams per mole. That will convert grams of sodium to moles of sodium. Then we need to go from moles of sodium to moles of sodium chloride. We know that 2 moles of sodium make 2 moles of sodium chloride from the balance reaction. And once we get to moles of sodium chloride, we're going to need to convert that to grams. So we're going to need the molar mass of sodium chloride, which is 58.5 grams per mole. Set question mark wanted, question mark grams of sodium chloride is equal to our limiting reagent given, 3.00 grams of sodium dot line. To cancel out grams of sodium, we put the molar mass of sodium in the denominator. 23 grams is equal to 1 mole. The grams of sodium cancel out. Now we need to convert moles of sodium to moles of sodium chloride. We put moles of sodium in the denominator to cancel out the units. We know for every 2 moles of sodium, we're going to make 2 moles of sodium chloride. Cancel out. Then from 2 moles of sodium chloride, we need to convert that to grams, so we're going to multiply by the molar mass. 1 mole of sodium chloride in the denominator is equal to 58.5 grams of sodium chloride, and the moles of sodium chloride cancel out. We multiply the numerators together and divide by the denominators, and we get 7.63 grams of sodium chloride, which is less than 10.4 because we have a limiting reagent. So this is how you solve limiting reagent problems. First, you have to realize you have a limiting reagent problem. And the clue is, when you're given the quantities of more than one species in a reaction, chances are you have a limiting reagent problem. In the last problem, we were given the amount of sodium metal and the amount of chlorine gas. We were given the amount of each reactant. That tells me I have a limiting reagent problem. Second, I need to convert the given quantities to moles if they're not already in moles. So if they're in grams, I need to convert them to moles. And then I divide each mole quantity by its coefficient. The smallest result is the limiting reagent. Use this limiting reagent to solve the rest of the problem. So let's try this. A 50.6 gram sample of magnesium hydroxide is reacted with 45 grams of hydrochloric acid, or hydrogen chloride in this case because it's not aqueous, according to the reaction, and it's balanced. The question is, which is the limiting reagent? So first, we need to realize we have a limiting reagent problem. Well, it asks us which is the limiting reagent, so it's obvious. But even if it didn't ask us, the fact that we were given the mass of magnesium hydroxide and the mass of hydrogen chloride, that tells us we have a limiting reagent problem. Then we need to convert the given quantities to moles. We have 50.6 grams of magnesium hydroxide. We divide that by the molar mass of magnesium hydroxide, which is 58.3 grams per mole, and we get 0.868 moles of magnesium hydroxide. We need to do the same thing with hydrogen chloride. We have 45.0 grams of hydrogen chloride divided by its molar mass, which is 36.5 grams per mole, and we have 1.23 moles of hydrogen chloride. Next, we need to divide each mole quantity by its coefficient. So we divide the moles of magnesium hydroxide by the coefficient of magnesium hydroxide, which is an assumed 1. So we get 0.868. Then we divide 1.23 moles of hydrogen chloride by its coefficient, which is 2, and we get 0.615. The smallest result is limiting reagent. The smallest result here is 0.615, so we know that hydrogen chloride is our limiting reagent. Let's look at another sample problem. A 20.1 gram sample of lead 2 nitrate is reacted with 25 grams of potassium iodide according to the above reaction. How many grams of lead iodide is precipitated? First, we need to realize we have a limiting reagent problem. How do we know this? We're given 20.1 grams of lead 2 nitrate and 25 grams of potassium iodide. We're given the amounts of each reactant. That tells us we have a limiting reagent problem. We need to convert these grams to moles. So we have 20.1 grams of lead 2 nitrate divided by the molar mass, which is 331.2 grams per mole. which gives us 0.0607 moles of lead-2 nitrate. We have 25 grams of potassium iodide divided by the molar mass of potassium iodide, which is 166.0 grams per mole. And we have 0.151 moles of potassium iodide. Next, we divide each mole quantity by its coefficient. For lead-2 nitrate, we notice that its coefficient is 1. So 0.0607 divided by 1 is 0.0607. And for potassium iodide, the coefficient is 2. So we're going to divide 0.151 by 2, and we get 0.0755. 0.0607 is less than 0.0755. So lead-2 nitrate is our limiting reagent. We're now going to use lead-2 nitrate to solve for how many grams of lead iodide is precipitated, because once all the lead nitrate is used up, the reaction is finished. We'll have leftover potassium iodide. So we're going to use this limiting reagent to solve the rest of the problem. So we want the number of grams of lead iodide given 0.0607 moles of lead-2 nitrate. The problem said 20.1 grams of lead-2 nitrate, but we just converted that to moles, so why not stay ahead of the game and not redo that part of the problem? Our conversion factors, we need to go from moles of lead-2 nitrate to moles of lead iodide. And from the balanced equation, it's a 1-to-1 ratio. And once we get to moles of lead iodide, we need to convert that to grams. So we're going to need the molar mass of lead-2 iodide, which is 1 mole of lead-2 iodide is equal to 461.0 grams of lead-2 iodide. Setting up our problem, question mark wanted. Question mark grams of lead-2 iodide is equal to 0.0607 moles of lead-2 nitrate, dot line. We know that 1 mole of lead-2 nitrate makes 1 mole of lead-2 iodide, so the moles of lead-2 nitrate cancel out. And we know that 1 mole of lead-2 iodide has a mass of 461.0 grams, so the moles of lead-2 iodide cancel out. We multiply all the numerators together and divide by the denominators, and we get 28.0 grams of lead-2 iodide. Another sample problem. A 100-gram sample of calcium carbonate is reacted with 50 grams of lead-3 phosphate according to the above reaction. Determine the amount of products produced. First, we need to realize we have a limiting reagent problem. We were given 100 grams of calcium carbonate and 50 grams of iron 3 phosphate. That tells us we have a limiting reagent problem. Then we need to convert our grams to moles. 100 grams of calcium carbonate divided by its molar mass, 100.1 grams per mole, is about 1 mole, or 0.999 moles in terms. 50 grams of iron 3 phosphate divided by the molar mass, which is 150.8 grams per mole, is 0.332 moles of iron 3 phosphate. Then we want to divide each mole quantity by its coefficient. The coefficient in front of calcium carbonate is 3, so we're going to divide this by 3, and we get 0.333. For iron 3 phosphate, the coefficient is 2, so we're going to divide this by 2, and we get 0.166. Since 0.166 is less than 0.333, iron 3 phosphate is our limiting reagent. So we're going to use this limiting reagent, iron 3 phosphate, to solve the rest of the problem. We want the number of grams, they want the number of grams of products, so we want the number of grams of calcium phosphate and iron carbonate. Let's work that out. Carbonate is -2, so that's -6, so it's still iron 3 carbonate. Given our 0.332 moles of iron 3 phosphate, we know that 2 moles of iron 3 phosphate make 1 mole of calcium phosphate, and 2 moles of iron 3 phosphate makes 1 mole of iron 3 carbonate. Once we have moles of calcium phosphate and iron 3 carbonate, we need to convert them to grams, so we're going to need their molar masses. The molar mass of calcium phosphate is 246.3 grams, And the molar mass of iron 3 carbonate is 291.6 grams. We'll have to do each problem separately. Let's start with calcium phosphate. How many grams of calcium phosphate is equal to 0.332 moles of iron 3 phosphate dot line? We know that 2 moles of iron 3 phosphate make 1 mole of calcium phosphate, and moles of iron 3 phosphate cancel out. And then we multiply this by the molar mass of calcium phosphate. We know that 1 mole of calcium phosphate has a mass of 246.3 grams, and the moles of calcium phosphate cancel out. We multiply the numerators together and divide by the denominators, and we get 40.9 grams of calcium phosphate. That's the first half of the problem. The second half is how many grams of iron 3 carbonate are made from 0.332 moles of iron 3 phosphate dot line. We know that 2 moles of iron 3 phosphate make 1 mole of iron 3 carbonate, so the moles of iron 3 phosphate cancel out. And then we know that 1 mole of iron 3 carbonate has a mass of 291.6 grams. So the moles of iron 3 carbonate cancel out. We multiply the numerators together and divide by the denominators, and we get 48.4 grams of iron 3 carbonate. I hope you enjoyed this video. To get more chemistry help and a free copy of my Amazon.com best-selling book, Solving Mole Problems, visit purplestoich.com. This is Melanie Fine of Chem in 10. I hope you enjoyed.